Last video, we went over our 5 basic log properties. Now we have 3 additional log properties to go over in this video. And number 6 says the log of a product equals the sum of logs. So if I can see a log base b of any base, and we have m times m, so I can see here that what is inside my log is being multiplied together. Then I can expand this out into 2 separate logs, both with that same base, log base b. We have m now plus n. So when I see they're being multiplied, we can expand that out by adding the 2 logs together. And this works the opposite way as well. If I see log base b of m plus log base b of n, see these are the same bases. Because they're being added, we can condense it into 1 log. So here, if I have log base 12 of 12x, I can't apply this property here because that x is not an exponent. So what I need to do is expand this out. So this would be log base 12 of 12 plus log base 12 of x. Because that 12 and that x are being multiplied together, expand it out with a plus, and they both have a log base 12. Now, log base 12 of 12 is one of my properties. If I have the same base and what it is of, then that's going to equal 1. So this will become 1, and I can't do anything here. So now we have 1 plus log base 12 of x. B, we're now going to go opposite. Now I have 2 logs. I'm going to condense it into 1. So because they both have the same base, they both have a base of e, we can make this the natural log of 18 times 25. And I know to multiply because these 2 logs are being added together. So 18 times 25 would give me the natural log of 450. Now 7 is very similar. It says the log of a quotient equals the difference of a log. So now if I can see I have a log base of any base and it's being divided within that log. Okay, this is being divided. Now I can expand that out. They both have a log base b. I'm going to split the numerator minus the denominator. But now we are going to subtract the 2 logs. I know it works both ways. If I see 2 logs with the same bases and they're being subtracted, I can condense it to 1 log by dividing. So we have log of 100 over x. Because this is being divided, I'm going to subtract. So log of the top one minus log of the bottom one. We can condense this. This is the same as log with a base of 10. We can rewrite 100 to be 10 squared. What my log base is and what it is are the same, just like here, and so it's going to equal whatever that exponent is. So this will become now 2 minus log of x. Okay, and if you don't like doing that, put it in your calculator. Log of 100 equals 2. Now we're going backwards. And if I have log base 5 of 40 minus log base 5 of 10, because they both have the same base, we can condense it. And because these are being subtracted, we're going to divide. So this is log base 5 of 40 over 10, which will be log base 5 of 4. My last property is the log of a power equals the product of the power and the log, and we will need this one. Log base b of m to the r equals r log base b of m. So what happened? I can take whatever this exponent is and move it out front to where it is now a product. So now it's r times the log base b of m. Or we can go the opposite way. If I see something in front of my log, I can take it and move it up into that exponent position. So for example, I have that x as the exponent. We can move it out front, and that's equivalent to x natural log of 4. Or if I see that out front, we will move it up to the exponent spot, and that is log of x squared.